more pancakes. We're going to go back to pancakes. Okay, so there's our recipe again. Suppose we have 3 cups of flour, 10 eggs, and 4 teaspoons of baking powder. How many eggs can we make? Quick. I hear 15. 15? How did you figure that out? Yeah, so you have to look at each of these and figure out how much it can make, basically, right? So if you had 3 cups of flour, you need 1 cup of flour for 5 pancakes. You get 5 pancakes per 1 cup of flour. You could make 15 pancakes, right? So 3 cups of flour. I almost said fluorine. 5 pancakes per 1 cup. So 15 pancakes. PC is pancake. The 10 eggs. 10 eggs. How many pancakes can we make from 10 eggs? 5 pancakes for every 2 eggs. So that's 25, right? And then we've got 4 teaspoons, 4 tisps of baking powder. And we can get 5 pancakes for every half tisp. Okay, I could write 1/2. I'd rather write 0.5 because writing fractions, especially when they're in the denominator, can get ugly sometimes. So I'm not going to trust my head on this. 4 times 5 divided by 0.5 is 40. We have enough baking powder to make 40 pancakes. Why can we only make 15? Because we run out of flour when we make 15. You can't continue making pancakes if you don't have flour. Right? Not with that attitude. I think the peanut gallery is behind that thing up there. Okay, so if this was a chemical reaction, we would say that the flour is the limiting reactant. The flour is the limiting ingredient because it limits how much product can be made. We're going to have some eggs and some baking powder left over. And that's a pretty common occurrence when you do baking or any sort of cooking, right? It's really unusual to make a cake from scratch and have exactly the right amount of flour and baking powder and everything in your kitchen. I mean, you don't go to the store and buy 2 eggs. You buy a dozen eggs. And so you probably have 10 eggs left over after you've used the 2 eggs. This happens a lot in chemical reactions as well. There's one ingredient that gets used up, one reactant. Okay, then there's the issue of life happening. So we're making the pancakes, and we got distracted and we burned 3 of them, and 1 fell on the floor. Now, your floor may be clean, but I have a dog with long white hair, and it looks like there's been a snowstorm at my house. If I drop a pancake on the floor, I am not going to pick it up and eat it because it's going to be furry if the dog hasn't already eaten it, right? Okay, so we had enough flour to make 15 pancakes, but we actually only ended up with 11 that we could serve. Could you imagine that happening? Maybe you flipped one too hard and it stuck to the ceiling, right? You're going to have to wait for it to fall down later. So if this was a chemical reaction, we would say that the 11 pancakes is our actual yield, and 15 is the theoretical yield. So you're going to make cookies, and it says, it gives the yield in the recipe, right? It says yield 3 dozen cookies. Well, that's assuming that you don't eat half the cookie dough, right? That you don't burn some, or that your kid doesn't take some, right? That is, in theory, this is the most you could make. So that's the theoretical yield. Everything works perfectly. The practical is the actual yield. That's the part that actually gets produced. Well, we often express that relationship as a percentage. So we call that the percent yield. In this example, our percent yield would be the number that we actually made, the part, divided by the whole, out of 15 pancakes that we should have been able to make, times 100%, and that's 73%. So our yield was 73%. If we had set out to make 100 pancakes and we had the same yield, we would have gotten 73 pancakes. So this is the general equation for percent yield. Percent yield equals the actual yield divided by the theoretical yield. I call him Theo, times 100. And again, we're treating percent as a unit there. Do not use any percent button that might show up on your calculator. You'll get the wrong answer. Well, how do we know what the actual yield of the experiment is? Well, you have to actually do the experiment and get an amount. It's going to vary. The actual yield is going to vary. When you make pancakes, you're not always going to wreck 4 of them. Sometimes you might wreck half of them. Sometimes you might not wreck any of them. The actual yield is almost always less than 100%. And in chemistry, what happens is that some of the product doesn't form, or some of the product is lost in the process of recovering it. You know, you're using a filter to catch it, and some of it got through the filter paper, or you spilled some on the floor, stuff like that. It is possible to have a calculation where the percent yield ends up being like 105%. But what that means is that something went wrong. That doesn't mean that you're super good. It means that something went wrong. It could be that some stuff fell into the reaction, and you know, we're usually doing this on mass. Well, if you've got some sand in there along with your product, it's going to weigh more than it should, right? Or if it's wet, the water will add mass to it. So if you get a percent yield that's greater than 100%, that means that something went wrong. So in summary, all these different yields. We've got the limiting reactant, sometimes called the limiting reagent. That's the reactant that gets completely used up, and it limits the amount of product, so it will make the least amount of product. The theoretical yield is the amount that you could possibly make if everything went perfectly. The actual yield is the amount that you actually produce, and there's, again, the percent yield equation. Okay, so let's look at this one. Titanium plus chlorine to make titanium 4 chloride. What are the limiting reactant and the theoretical yield if you start with 1.8 moles of titanium and 3.2 moles of chlorine? Well, how did we figure out the pancake problem? We took each ingredient and figured out how many pancakes we could make. We're going to do the same thing with chemical reactions. So we're going to use stoichiometry to find the amount of product that we can make from each reactant. And then we're going to figure out which is the smaller, and that's our limiting reactant, the one that gives the smaller yield. And the theoretical yield is equal to that smaller yield. So let's do this step by step. So 1.8 moles of titanium. Again, I like to use the equation. So 1.8 moles of that, and I've got 3.2 moles of this. Are we going to do grams to moles to moles to grams here? No. They gave us moles. We're skipping the grams on each end. Okay? We're just doing moles to moles. So our overall plan is grams to moles to moles to grams. Except we don't have grams at the end, and we don't have grams at the beginning. We're just going to do the middle part. Don't turn it inside out and do moles to grams to grams to moles, because that doesn't work. Just chop the ends off. So I need to do two calculations then. I need to do 1.8 moles of titanium, and I need to figure out, oh, I forgot to put the question. What are we trying to find? Theoretical yield of what? Well, it'd have to be this one. There's only one product. So we want to know this. I need to rewrite this question to say moles. So 1.8 moles of titanium times, I want moles of product over moles of titanium. Well, what number goes in front of TiCl4? 1. And what goes in front of Ti? 1. For every 1 mole of this, I'm going to make 1 mole of that. Well, this one's pretty easy. 1.8 moles. TiCl4. And then I'm going to take the other one and figure out how much product. So I did the flour, and then I'm going to do the eggs, and then I'm going to do the baking soda or baking powder, except here there's only the 2 ingredients. 3.2 moles of O2, and I'm going to moles of the product, and I'm dividing by moles of this starting amount. Yeah, that's not an O. It's very small on my little iPad mini, and the CL kind of looks like an O. There we go. 3.2 moles of Cl2, and then we're going to get 1 mole of this for every 2 moles of that. 1 mole of TiCl4 for every 2 moles of that. So that's going to give us 1.6 moles of TiCl4. We have 2 answers. We can't stop here because we have to choose one. Choose the smaller one, just like with the pancakes. As I'm going along making TiCl4, when I get to 1.6 moles, it stops because I'm going to run out of chlorine. You can't make TiCl4 without an ECl. This is the theoretical yield. Theoretical yield. So you do the calculation for both. You find the one that makes the smaller product. That's your theoretical yield. The one that makes that is our limiting reactant. So this guy over here, that's our limiting reactant. Any questions?